Derivatives and rates of change, part 6. So we want to arrange the following in decreasing order, so from greatest to least. So we have f of 1, f prime of 1, f prime of negative 1, f of 3, and f prime of 5. Recall that f of x is going to give us an output of y, and f prime of x is going to give us an output of the slope of the tangent line. So for some of these, we're looking at just the y, the output there, and for some of these, we're looking at the slope. And because we don't have any scale on our y-axis, that means we're going to have to do a little bit of approximation. So we can guess that it's probably going to be about the same-ish scale. And then let's find each of these. So let's start with f of 1. So that is the output y at 1, which will be 0. And then we need to find f prime of 1. So that'll be the slope at 1, which we kind of have to approximate, but it looks like the slope is just about 1. Depending on how well I drew that tangent line. So it's definitely an approximation. Then we need f prime of negative 1, which I'll actually use green for, so that's a little easier to see. So f prime of negative 1, so that'll be the slope at negative 1. So that'll be the slope here. Which I'm going to say is about negative 2 or negative, well, that's pretty steep. I'll go with negative 3. It's an approximation. You know, we'll see if the other ones need me to be a little more precise with that. But it's negative, and it's definitely steeper than f prime of 1. Then let's find f of 3. So that'll be here. Our output at 3, which is about 3. And then we need f prime of 5, which will be the slope at 5, which looks like it's about negative 1. And then I want to arrange these in decreasing order. So that'll be f of 3 is my greatest, then f prime of 1, then f of 1, then f prime of 5, and last but not least, f prime of negative 1. So you just have to approximate each of the values and then list them from greatest to least. A particle moves along a straight line with the equation of motion. S is equal to f of t is equal to 80t minus 6t squared meters, where t is in seconds. Find the velocity when t is equal to 2 seconds. Recalling that the velocity is equal to the derivative s prime of the position function, so that'll be equal to f prime of t. We'll start by finding f prime of t so that we can find f prime of 2. So f prime of t will be equal to, using our limit definition of the derivative, the limit as h approaches 0 of f of, usually it's x plus h, but here our input is t, so we have t plus h. So that'll be 80 times t plus h minus 6 times t plus h squared minus f of t, so that's just our 80t, minus 6t squared all over h. Let's distribute that 80. So we have the limit as h approaches 0 of 80t plus 80h. Then let's square this t plus h. So we have minus 6 times t squared plus 2ht plus h squared. Then distribute our negative, or our minus. So we have minus 80t plus 6t squared all over h. 80t minus 80t will subtract out. Then let's distribute that minus 6. So this is equal to the limit as h approaches 0 of 80h minus 6t squared minus 12ht minus 6h squared plus 6t squared all over h. And now we have these 6t squareds that we'll subtract out. So this is equal to the limit as h approaches 0 of 80h minus 12ht minus 6h squared all over h, and we just have a bit more simplification to do. If we look at our numerator, we have an h in each term, so we can factor that h out. So f prime of t is equal to, sorry, I don't want to write it again, is equal to the limit as h approaches 0 of h times 80 minus 12t minus 6h all over h. Now our h's will divide out. So this is equal to the limit as h approaches 0 of 80 minus 12t minus 6h. And we're looking at the limit as h approaches 0, so our t will not be affected. And this is equal to 80 minus 12t minus 0. So we found f prime of t, but we're looking for the velocity at t equals 2 seconds, not just the velocity. So we have to substitute 2 into our function. So v of t, the velocity at, v of 2, the velocity at 2 seconds, will be equal to f prime of 2, which is equal to 80 minus 12 times 2. So that's 80 minus 24, which gives us 56. Then we need units. So we have meters per second. If the tangent line to y is equal to f of x at 7, 2 passes through the point 0, 1, find f of 7 and f prime of 7. F of 7 is just your output y at x is equal to 7. F prime of 7 will be equal to the slope of the tangent at x is equal to 7. So if we look at this, we have y is equal to f of x, and that passes, the tangent line to that function passes through 7, 2 and 0, 1. You don't need to sketch a picture, but it might help you visualize this. So we have the point 1, 2, 3, 4, 5, 6, 7, 2. And we have the point 0, 1. And this is the tangent line. So this is our f prime of x. Specifically, it's the tangent line through this point for some function that we have no idea what it looks like. But we do know what its tangent line looks like. So, first let's find f of 7. So that's, we input 7, what do we output? Well, the only point we have for our function is the point 7, 2. And when we input 7, we output 2. So that's one piece. Now we need the slope of this tangent line at 7. Since this is the tangent line and we have 2 points on this tangent line, that's finding the slope between these 2 points. So f prime of 7 will be equal to 1 minus 2 over 0 minus 7. 1 minus 2 gives us negative 1 over negative 7. So f prime of 7 is equal to 1/7. And that's just the slope of our tangent line. So the slope of this line here. Up 1 over 7.